Hello, this is our presentation number 5, Design of Experiments for the class Engineering 305. My name is Andres Corova and my teammates for this presentation was Yasan and Ferris. And here's an overview of our project. First, we're going to start with the main elements of a design of experiment, datasets for a design of experiment, the meaning of creating and design and performing it, underlying models in a design of experiment, when to perform a design of experiment, and a response surface method for a design experiment, profiling and optimizing using the RSM, which stands for response surface method. So the main elements of a design experiment are responses, factors, constraints, and the number of runs. The responses are basically the numbers to be predicted in a design experiment. The factors are the inputs who will determine the responses. Constraints, any special conditions for the given factors, and the number of runs. For the design experiment, we want to minimize it. These are the datasets that we selected for our design experiment. The first one is the popcorn design experiment results that we use in class, and the laptop results. So basically we're going to use the factors that are as brand, time, and power to determine the number of pop kernel out of the total kernel.
And now we're going to talk about the meaning of creating a design and performing it. Creating a design experiment is basically creating a table with the corresponding inputs in order to determine the responses for the given values with the purpose of reaching a certain goal, which can be matching a certain target, maximizing what we want, or minimizing. And with the performing the design itself, using the created table for design experiments, we can perform tasks using this table to reach a goal like maximizing the response, as we said before. Now for the underlying model in the DOE, for this data set that we have to use, we thought that the multi-regression method seems to fit the most, because in the design of experiments, many factors are considered to determine the expected response. The multi-regression method is the one who predicts an output using many factors as input. We discarded the logistic regression because the response is not categorical, but it was continuous. And now let's look at our data for a second. Here, for the popcorn DOE results, we can see that the total kernels depended on the number popped, the power, the time, and the brand being a top secret or Wilbur. And for our other dataset, laptop results, the price for each laptop depended on the battery life, being it 4 hours or 6 hours, the speed of the processor, and the disk size, etc.
Now we are going to discuss the differences in models. We perform a DOE when we are trying to create a design of experiment with less amount of runs using continuous, categorical constants, and other factors. This model does not have to be quadratic. It is best if the non-important factors are discarded. Moving to the response surface method DOE, it involves a small number 2 to 8 of continuous factors. For this model, the priori response is usually quadratic, and it is used when the important factors are known. Profiling and optimizing using a RSM. We can create the prediction profile table using the fit model once the DOE is completing. Optimizing using a RSM. After creating the profile in JUMP, we can calculate the desired output by clicking the red down arrow in the Prediction Profiler section. Thank you for listening.